Hey everyone, let's solve today's LeetCode challenge, which is sum of absolute differences in a sorted array. So here in this problem, we are given a list of number arranged in order, and for each number in the list, we want to find the sum of the absolute differences between that number and the every other number in the list. So for example, for this case, we have for the first index 2, we have to find its absolute difference with each of the other element in the array, which is 2 3 5. So let's say for this for the first number 2, the sum is 2 minus 2 modulus 2 minus 3 modulus 2 minus 5 modulus, which is 4, and so on for 3 and 5. Okay, so how do we do that? First approach is like checking for all the possibilities, or maybe following the same what is mentioned in the problem, like checking 2 with all three elements, checking 3 with all three elements, checking 5 with all three elements. So that is going to be n square, which is not a very optimized approach. So what else can we do? This problem is also in the problem it is also given that it's a integer array which is non-decreasing. So let's say for this given input, if we have to check for 3, how do we check? The absolute difference with itself is always 0. So 3 is done. So now we have to process from left side and right side. And for the right side, all the elements are always going to be larger than 3. So we need to find the difference with each element. So what we are going to do is we will calculate the sum of each element and subtract the 3 from each. So which is one element in the right side. So we are going to subtract 3 from it, which would be 2. So from the left side, we have to subtract each element from 3. 3 minus 2, which is 1. So for 3, our answer would be 1 plus 0 plus 2, which is 3, which is also mentioned here for 1. Let's try to have a look on a larger example so you will get more idea. 1, 4, 6, 8, and 10. And now we have to check for 6. For 6, if we take the modular with itself, it is always going to be 0. From the left side, we are going to subtract each element from 6, which is 6 minus 4 is 2, 6 minus 1 is 5. From the right side, it is all the elements are greater, so we are reducing 6 from each element. 8 minus 6 is 2, 8 minus 10 minus 6 is 4. So this is going to be our answer, which is 30. How do we approach this problem? What we can do is we can check for the prefix sum. Firstly, we will pre-compute the prefix sum, and using that, if we do the iteration over the array, we are able to find like what is the sum of elements on the right side, sum of elements on the left side. So let's say in this case, if we do the prefix sum 1, 4, 6, 8, 10, prefix array would be like 1, 5, 11, 19, 29. Okay, so this is our prefix. And let's say if we have to calculate for 6, what we need is we need sum of all the elements on the left side, and we can directly reduce that from the same number of 6. Let's say we have 2 elements on the left, so we will multiply 6 with 2 and subtract that sum, the sum at the left side. And for the right side, we will check how many numbers are there on the right side, which is 2. So for the sum of all the elements on the right side is like that we can directly calculate, which is 29 for whole array and 6 11 till 6. So if we reduce 29, and if we take a difference from 29 and 11, so we are going to get 18, so which is sum of elements on the right side. So sum of element on the right side minus 6 into number of element on the right side. Sum of right side element will always be larger because it is a sorted array. So in this way we can calculate the sum of left side and right side. Let's try to finish the example for 6. For 6, the left side we have 2. Maybe let's say n is equal to k is equal to 2. So sum of element on the left side is prefix of I minus 1, which, or maybe prefix of 1, 11 minus 6, which is 5. 5 should be subtracted from 6 into 2. 6 into 2 minus 5 would be the left side sum, or maybe left side answer. For the right side, the sum of elements at the right side, that we can compute from our prefix array, which was 18, minus 6 into number of element on the right side, which is 2, which is 6. So the answer would be 13, which we calculated in our answer, which is same. So now how did we approach this problem? We can just calculated the prefix sum array for the given input and iterated over the given input and used that array to solve our answer. So in that case, we just did some pre-computation, which is on time, and then so calculated our answer, which is on. So 2n is also on. So we have now solved this problem in the linear time. Let's try to code this problem. Here, let's capture the length of the given array. Now we will calculate the prefix array for the given input. Now we will calculate the prefix array values. Prefix I is equal to prefix I minus 1 plus nums of I. As we are using prefix I minus 1, we will start from 1, and for 0 we can directly say that prefix of 0 is equal to nums of 0. Okay, now we have the prefix sum, and let's take a answer array, new integer of n size, and we have to calculate for every integer in the given nums array. I equal to 0, I less than n, I plus plus, and after calculating the answer we are just going to return that. Now what we have to do is we have to take the modulus from each element. So modulus to itself is always 0, so no need to consider that. Modulus from all the left elements, all the left elements are smaller than the current element, so we will reduce the sum of all the left element from the current element, which is nums of I minus nums of I into the number of elements on the left side minus the sum of left element. So firstly calculate get the left sum in the current input, which is equal to prefix I minus 1. Here what we will do is we will check for I, because we don't want to add an extra condition for I greater than equal to 0, greater than 0. So prefix of I minus nums of I. So this is our sum for all the elements left side. So let's say for 3, this is going to be sum of 2, or maybe for 2 this is going to be sum of all the elements on the left side. Prefix 0 minus nums of 0, which is 0. Int right sum. How do we calculate the right sum? Prefix of all the elements in the array, which is at the left end, last index, minus में nums of I. Okay, now we have the left sum and the right sum. Now we have to calculate the number of element on the left side. Left count, or maybe int right count. Count of element at the left side are equal to I, because I is starting from 0. For 3, I is 1, and number of element on the left side of 3 is also 1. For the right side, let's say for 3, how many elements are there on the right side? N minus I, which is n minus I minus 1. N is 3 here, so 3 minus I is 1 minus 1. So n minus 1 minus I. Okay, so left answer. Now we have to calculate the answer from the left side, which would be equal to nums I into left count minus left sum, because left sum is lesser. Int right answer is equal to right sum is always greater than minus nums I into right count. So now what we can do is we can capture that in our answer. Answer I is equal to left answer plus right answer. Okay. Now let's try to submit the problem over test cases, sample test cases. It's giving me a wrong input. Let's try to figure out what's the issue. So here we calculated our sum, right sum wrongly. Now we have to subtract the total sum minus sum of all the elements at ith index, which is prefix of I, not nums of I. Now let's submit again. Submitted. Okay, successfully run on the over the sample test cases. Now submitted the problem. Okay, submitted successfully. Okay, hope you understood the problem. Thank you guys.